What's up, guys? It's Mr. Bringle, and today we're going to be talking about part three of the graphing practice. And today is all about making what we call physics equations from our graphs. And this is really just an equation or a mathematical expression that explains the data that we're looking at on the graph. So it's something that we can take the graph, we can make an equation based on the graph, and then we can actually use that to predict values that are not on the graph. And it turns out a lot of these equations you'll see when we actually are in our velocity unit acceleration forces, the equations that we pull off of the experiments that we graph are actually the equations that you'll use on your equation sheet to do math problems with. So this gives you a way to really see why we're using these equations and where they come from. So very practical. You don't really necessarily need to worry about the content here. We're just practicing making the physics equations. So I don't expect you to know anything about pressure and volume or anything like that. Okay. So we should have already talked about physics equations in class. And if not, there is a tutorial in the graphing playlist. So let's jump into this here. We've already done parts 1 and parts 2 here. I have my linear graph. The physics equation is only for linear graphs. What I'd like you to do is go ahead and just kind of type physics equation in one of the boxes over here and put your linear graph right underneath it. If you would like to set yours up like mine, what I did here is I clicked this button up here, which allows text wrapping. So that way things will go down to a different line for you instead of stretching all the way across here and having to stretch this box out. You can just use this little button right here, text wrapping. Now, next to it, I'm actually going to merge some of these cells together here so we can type right in here. So I'll highlight those, and then we'll find the merge button, which looks like this, and we'll click that. Okay, so now we can type in here. What we're going to do first is I'm going to kind of do it on the screen by writing, and then we'll type it in. But just remember that what we're trying to do here is use the equation format of y equals mx plus b. Remember that that's the format of, or the equation for a line. And that's where this comes into play. The equation that we put on the graph is in the format of y equals mx plus b. So it obviously doesn't say y equals, but it gives us m, the slope of 4 on this graph, times x plus the y-intercept, which in this case was at through the origin or 0. So we need to take values from that equation and make our physics equation, okay? So the first thing is the y-axis, right? Y is our y-axis, which in this case is pressure. So we're going to end up putting pressure. We're going to write out any of the words that are on our axes. I want you to write them out. So we'll write pressure is equal to, slope is a numerical value that it gave us on the graph, so we're going to put it in as a numerical value. It's going to be 4 because that's what it gave us in the equation right there, okay? Now, the key here is getting the units, okay? And I did this in the physics equation tutorial, but I like to write out rise over run, okay? And then we know that pressure, so I'm going to put a capital P up here for pressure, divided by 1 over volume. Okay, so that's going to make things a little bit tricky. We didn't do any, we didn't have an example like that on the tutorial, but I'll walk you through it here. So now let's type in the units that we're going to be using. So the units for pressure are pascals, PA, over 1 over meters cubed. Okay, so this is really confusing, right? There's a lot of things going on here, and that's not very useful for us. So you can't ever leave units like this where we have multiple fractions. If you have a fraction within a fraction, we got to get rid of it. So the way to do this is to go ahead and multiply the denominator here by its reciprocal, okay? So meters cubed over 1. And then we will also do the same thing to the top. Meters cubed over 1 multiplied by pascals, okay? So you can see what will happen here is that the meters cubed on the bottom, this is all going to cancel here. Now what we're left with is pascals times meters cubed. Those would be our final units. Pascals times meters cubed, okay? So again, all I did here is I multiplied the denominator by its reciprocal. And if you multiply the denominator by something, you'll have to do the same thing to the numerator. So we also multiplied the numerator by the reciprocal of the denominator. This gives us pascals times meters cubed, okay? So I'm going to put that in right here. So pascals times meters cubed, those would be our units. Just remember, the units are not important right now in terms of like, I don't need you to know what that means or anything, okay? I just want to go through the process here. Okay, now we're going to multiply by the x-axis, which in this case, the word that's on our x-axis is 1 over volume. So that's what I'm going to put here. I'm going to put 1 over volume. I'm just going to write, for the sake of, well, we'll go ahead. I can fit it in here. So, okay, so pressure is equal to 4 pascals times meters cubed times 1 over volume plus the y-intercept, which in this case is 0, which I'm again getting from this equation right here. And the y-intercept always has the same units as the y-axis. So the units here would be pascals, okay? So really the pressure, this would be the final pressure. This would be the initial pressure, okay, your starting point. And then if we wanted to predict, where if we had on our x-axis here, if we wanted to predict something that was off to the right, we could then do that by using this equation here. Okay, so the point here is what you're going to type in up here. I want you to practice writing these in. So you're going to write pressure is equal to, and then in parentheses, 4 pascals. To do multiplication, use the asterisk. Okay, so it's shift and 8 to do that. Times a meter cubed, which we'll just use the caret symbol and a 3 for cubed. Okay, end your parentheses. Now start a new parentheses and write 1 over volume plus 0 pascals. Okay, so this right here, I'm going to go ahead, we'll make this red here. That is your physics equation for this linear graph right there. Now, I just copied what we had down at the bottom, but you'll just type it in on your assignment here, okay? Now, let's go ahead and erase all this, and then I'm going to go ahead and move on to the next one. I don't expect you to understand this right off the bat and be like, oh yeah, I get this. This totally makes sense, okay? In fact, that was probably not the best example to start with because the units for slope are a little bit complicated there. But as we do more practice and as you keep doing these, it's going to click for you. So just keep working. All right, let's move on to graph number 2 here. Okay, so once again, I wrote down physics equation for linear graph right here. I used the text wrapping. I'm going to go ahead and merge these cells right here so that I can type in there. Okay, but I am going to go back and do this by writing just so that we can keep things consistent. And so remember, y equals mx plus b. That's our format here. Whatever's on our y-axis is what we're going to write down for that first part. So it's position. So position is equal to the slope. Remember that slope is going to be found from our equation right there. The slope for this graph is 3. Okay. And then we need to figure out the units for the slope. So once again, rise over run. Our rise or y-axis is position. I'm going to put POS for position over the run, which is our x-axis. And in this case, it's time squared. Time squared, okay? So if we just replace these with units, what are the units for position? They're meters. What are the units for time squared? Seconds squared, okay? So these right here are your units for slope. Now, I don't have to do anything extra. I don't have to multiply by reciprocals or anything like that because we don't have 2 fractions here. All we have is 1 fraction. And so we're good, okay? So now I can go ahead and type in my units here of meters per second squared. Okay, we'll go back to red here. All right, now I also want you to know that this, so meters over second squared, the way I wrote it there, and this right here, these two are the same. Okay, that's the same. It does not matter how you write that. Okay. Now, going back here, the next step, since we've done the position for y, we did 3 meters per second squared for the slope. Now let's look at the x-axis, which I guess I'll go ahead and I'll draw an arrow here. The x-axis is labeled with time squared, so that is what we are going to write in right here. Okay, and then we will look at our y-intercept. Now, the y-intercept, b, is this crazy number right here, okay? 4.06 times 10 to the negative 15. That's what that means. So that E, you can just read that as times 10 to the negative 15. This is scientific notation. So this is such a small number. It's 0.0. There's 14 zeros and then 406. So that's so small, you don't need to include it. That is as good as zero, okay? We're going to go ahead and put in 0 here. And then remember, the units for the y-intercept should always be the same as the units for the y-axis, which means that this would be meters here. Okay, so now this right here is our physics equation. So I'm going to go ahead and type it in the way that I want you to. Okay, so you're going to write position is equal to, in parentheses, 3 meters per second, so m/s, then caret 2, because we want meters per second squared. Okay, we'll get into this here in our next couple units, but there's a big difference between meters per second squared. Meters per second is for velocity, and meters per second squared is for acceleration. We'll multiply this now by time squared, and then you're going to add 0 meters. Okay? But right there is a finished physics equation, and we are good to move on. Once again, if we look at this, and let me kind of clean this up a little bit, get rid of some of this. I'm going to go ahead and wipe that. So if you think about it, right, like if we're looking at this equation and you said, okay, well, what if we wanted to find out something that was over here, like on the number 30, right? You would plug in 30 for time squared, and then we can predict where the position will be, right? All we have to do is multiply it by 3 meters per second squared. Okay, well, there's no y-intercept, so we don't have to worry about that. So we could predict how far the line would go out over here. All right, you do not have to do anything with graph number 3 because it's already linear. So we're just going to take a look at this graph right here. I'm going to go ahead and I'm actually going to copy my physics equation there for the linear graph, and I'm going to plug it in right here. And then I'm going to merge these cells just so we have somewhere to type. Okay, so we don't have to deal with a second graph here. We'll go ahead and just use this one since it's already linear. Same thing. Actually, sorry, I want my red pen here. Okay, so y is equal to mx plus b. The y-axis is velocity, so you're going to write velocity is equal to, your slope is negative 3.02 based on the equation. So please make sure to include that. That negative sign really matters. That tells us that it's sloping downwards. Okay, and then here we go. We got to figure out our slope units. Okay, so rise over run. This time we've got velocity. I'm going to put VEL over mass. Okay, now what are the units for those things? That would be meters per second over kilograms here. All right, so here we go. We have another situation where we've got two fractions. We've got a fraction within a fraction here. So we want to simplify this by getting the denominator up on top into the numerator of the larger equation here. Okay, so we're going to go ahead and multiply by the reciprocal again. So the reciprocal of kilograms would be 1 over kilograms. Okay, because you could just write this as kg over 1, right? So now you can see that this is all going to cancel here. But remember, if we do this in the denominator, we also have to do it in the numerator. So we're going to multiply meters per second by 1 over kilograms. Okay, so now what this is going to give us is meters over kilograms times seconds, or seconds times kilograms. It does not matter how you write that. Okay, so those are going to be our units now. I can write those in. So meters over kilograms times seconds. Okay, and I'm going to actually kind of put all of that in an extra parentheses there, so that you can tell that those are the units. I'm not going to do double parentheses or anything because they're in different colors. All right. Okay. So the next thing would be to multiply by whatever's on our x-axis, which is the word mass, plus our y-intercept, which in this case is actually a number now. So 25.5, and then the units are always going to be the same units that are on the y-axis. So this is, since velocity is on our y-axis, we will put meters per second here. Okay. All right. So once again, let's go write this in on the document. So we would type velocity is equal to negative 3.02, and then meters over kilograms times seconds. Okay. If you just want to do one big parentheses here, that's fine. I know what this is supposed to be. If you want to put in extra parentheses there, that's fine. And then we're going to multiply that by mass, because that was on our x-axis, plus our y-intercept, which is 25.5 meters per second. Okay. So we're now done with our physics equation for the third graph here. Go ahead and erase that stuff. And once again, we can predict values using this equation here. So if we knew what mass we wanted to look at, we could go ahead and plug that number in right here for mass, multiply it by negative 3.02, and then add 25.5 onto it, and that would give us our final velocity there. Okay, so last one here, and I'll make this slightly smaller. Okay, so let's do the same thing. Always the same. Y equals mx plus b. The y-axis is labeled with velocity squared. So I'll write velocity squared is equal to our slope, which in this case is 56.6 for the numerical value. And then we do need to figure out our slope units. So the rise here is velocity squared. The run here would be time. Okay. So if we're looking at units here, our units would be meters over seconds squared. Actually, both of these are squared. Okay. Because it's velocity squared. So that means that both the meters and the seconds get squared. And then that is all over, let's go ahead and put that in parentheses. That's all over time, which is in seconds. Ooh, that's busy. That's busy. Okay. So let me click somewhere else on the graph here too. So what we want to do here is, once again, we got to get this denominator out of here. So multiply by the reciprocal, 1 over seconds, right? These cancel. Do the same thing up here. Multiply by 1 over seconds. Okay. So what this is going to leave us with is meters squared over what happens when you multiply seconds times seconds squared. You get seconds cubed. Okay. So you're gonna do meters squared over seconds cubed, and that's what we're going to put in on our final equation down here. Okay. So go ahead and switch back to red here and finish that. We will multiply this by what's on the x-axis. That happens to be time. And then we will look at our equation to get the y-intercept, which is right here, at negative 10.5. So instead of doing plus, we would actually do minus 10.5 meters squared over seconds squared here. Okay. You could also do plus negative 10.5 if you wanted to put it in parentheses or something. Sometimes people find that easier. That is totally up to you. Okay. So let's go back over here. We'll go ahead and merge these real quick, and I'll go ahead and type this in. So we're going to do velocity, and then to square it, just use the caret 2. So velocity squared is equal to 56.6 meters squared over seconds cubed. So a lot going on there. Put that in parentheses. We'll multiply that by time, and then minus 10.5 meters squared over seconds squared. Okay? So that would be our physics equation for this graph. So once again, I know this might be a little bit overwhelming. We haven't talked about any of these things before, like velocity and time and pressure and velocity mass, all these things. So don't worry about the content. Just practice making the physics equations and understand that we can then predict values that are not on our graph. Okay, that's the main point here. So we will continue to work with this. We'll continue to do some practice. So don't worry about it if you're a little bit confused. Just make sure you ask questions if you're having trouble with it. Have a great day.